Hi, I am going to do 9 to 11. I had a student ask about it. It says that some sources report that the weights of full-term newborn babies have a mean of 9 pounds and a standard deviation of 0.6 pounds and are normally distributed. So I'm asked to find some probabilities, and so the key I see here is normally distributed. Because they're normally distributed, I will use the normal distribution, that curve that looks like a bell curve, to find the probability. And StatCrunch has a calculator that I'm able to use that's called the normal calculator. So if I go to Stat Calculators and come down to normal, I have my normal calculator. Now this problem told me that the mean was 9 pounds, so I can put 9 pounds in here, and the standard deviation was 0.6 pounds. And I want the probability that they will weigh between 8.4 and 9.6 pounds, or within one standard deviation of the mean. Remember, the empirical rule said within one standard deviation is about 68%. So let's see what happens when I do this. I'll put between, and I see 8.4 and 9.6. So I did toggle from standard to between because I had a lower bound and an upper bound, and I hit compute. And look, I get that 68%. This asks me to round to 4 decimal places, and so I'm going to put 0.6827. Check that answer. And part B says, what's the probability that the average will be within 0.6 pounds of the, average of 4 babies' weight. So this is a sampling distribution. So that means the standard deviation will be divided by the square root of n. N is 4. The square root of 4 is 2. So when I go back into my StatCrunch, I'm going to keep everything the same, except my standard deviation will be 0.6 divided by 2, which will be 0.3. And that gives me 0.9545. That most of the babies born will be in there. Remember, that's from 4 babies' weights. That's a sampling distribution. That's why that's different. I use the standard error instead of the standard deviation. So 0.9544, I think it was. And when I explain the difference, so I've explained the difference. Let's see how they write it. The distribution of the means is taller and narrower than the original distribution. Therefore, the distributions of means will have more observations located closer to the center. And that's why I had 95% of the observations there instead of 68%. And that is how you would do that problem. Keep sending them to me.